this so that I can record it for you. So we're now officially recording, yay. Anyhow, homework 9 was some polar coordinate stuff. So if you have any questions about that, you can ask now. Send a little chat. You can put it in the chat if you want, or you can just speak up. Homework 10 is triple integrals. And the first few are sort of straightforward, but then you get into applications of it, and that's when we're doing things like center of mass, which become very tedious calculations. So some of you will start them and say, hell with it, I'm not going to finish these take forever. Some of you will not. Some of you will say, okay, I'll suffer through these calculations. Or you'll get real good at setting them up and then figuring out how to have the machine do it for you, which is always nice. That's a skill that we should all be good about. But anyhow, well, I think what we should do is we should start with doing an example just so you see how the basic ones go, and then we'll move forward. So what did we do last class? We introduced triple integrals. But we're not going through the details. It's just so similar to the first and second dimension case that we're not going to go through it. So we're not going to do the Riemann sums. So let's do an example. So we'll do one similar to the homework problem. So let's say we have something like 1 to 4, 0 to 2, 0 to 3 of, I don't know, we'll pick something basic. X, y squared, z, dx, dz, dy. Now remember, Fubini's theorem tells us it doesn't matter what order we do at x, y, z. It doesn't matter. So I'm just for the heck of it, I'm going to do dx, dz, dy. Doesn't matter. Now you guys know from double integrals that sometimes it's in your best interest to reorder these things, but in this case it's not. This one's a very straightforward one. So what I'm going to do is I'm going to just integrate the x first. So it's going to be useful if I use different colors, I think, to help illustrate what's happening. So I'm only integrating the x first, so I can think of z and y as constant. So I'm going to put y squared z here, and then I'm going to put a bracket like this, and then I'm left with z and y. And so what's the integral inside? Well, if I change my color to be very clear here, my integral inside is, since it's x, this becomes x squared over 2, and this is from 0 to 3. Make that a little more clear. So that's again, I'm treating y and z as constants. So when I go to integrate this, well, what does this become? This becomes 3 squared over 2. So that's 9/2. And then when I plug in 0, I don't get anything. So I can write this as nine halves, the integral from 1 to 4. And then I'm going to do my z next, so I have this y squared. And then just to help illustrate this for you guys, I'll use this in terms of, I'll put my z in purple so it's kind of more clear, and then I'll go back. to the black for my y. So you can think of this as sort of a grouping symbol. We're going to do the z's by itself. Does anybody have a question at this point? Okay, so when you integrate z, this becomes z squared over 2, right? Z squared over 2. And then when I plug the bounds in, maybe I'll put it here. So I'm going to have 9/2, and then this is the integral from 1 to 4. And this integral, all it's going to become, if I switch my colors, is it's going to become z squared over 2. So you're going to get 2 squared over 2. And then all that's left is my y squared dy. So if you clean up your constants, and I'll do this on the next page, you get 4 over 2, which is 2, and then 9/2 times 2 is just 9. So this just becomes 9, the integral from 1 to 4 of y squared dy, I believe. Let me double check. Is it 1 to 4? Yeah, 1 to 4. And so this is a pretty straightforward integral. You get 9/3 y cubed from 1 to 4. And so you're left with 9/3 64 minus 1. So that's 63 over 3 times 9, or however you want to do it. So before we finish this, does anybody have a question? So this becomes 21 times 9, and then your final answer is 189. Any questions, comments? So this one was particularly, it's not short, it's a little tedious, but there's nothing thought-provoking about it. As long as you just follow the procedure and integrate in order, there's no, it's a mindless computation. But if you look at problems like number 1, C and D, then it becomes a little more difficult because you have to think about what order are you integrating, and then also your bounds have variables in that case. So, for example, you'll notice in D that you have bounds in the 2 interintegrals. That is very common when you have a triple integral. Does anybody have any questions? I'm not going to do C or D because we're going to do problem 2, at least pieces of it. Notice I say in class we computed because that's what we're going to do. So that'll give you an idea of how this works. Any questions? You hear my kid? Ricky, she broke her arm yesterday. She has a cast. Ricky, come here. She's having a hard time. Now, I gotta figure out how to get these to work on my computer. That way you won't hear the ambient sound of everything in my life.
You have
Apple ones, and my computer recognizes them, but it won't let me. It says that they're connected to the Bluetooth, but I can't figure out how to get them to work properly. So I'll figure that out.
I got mine to work.
Yeah. I don't know. We'll figure it out. All right. So let's look at another example, and this is going to be problem 2 on the homework. So we have a triple integral over some region in three-dimensional space, and we're integrating 2x dv. And what is d? So I'm describing this a little different than we described things in the past. D equals the region in the first octant. So this is a word we haven't used since the beginning of the semester. In three-dimensional space, the coordinate system breaks us into eight octants. And it's under the plane 2x plus 3y plus z equals 6. So there's a name for this type of plane, and when you restrict it to a quadrant, it's called a simplex. Maybe you've seen that before, I don't know. You can kind of, we're going to draw it in a second, but you can kind of imagine it looks like a prism. So let me just give you a general picture of what it looks like right away. So I'm going to share my internet page for a second. So if you look at this picture on the right, this is an example of what it's going to look like. If you take a plane and you restrict it to the first octant, it makes this sort of solid that has a triangular roof. It's kind of like a tent. So we're going to explain how you can visualize that in a second. Another way to visualize that is to clearly go to GeoGebra and play around. So again, how do I create this? Well, this green thing is a plane, but if I restrict it to just being over this one portion, then it looks like this. So we call these simplexes. That's just sort of the fancy name for them, prisms. I don't know. Okay, so does anybody have a question about that picture? Yeah. All right, let's go back to our whiteboard. All right, so how can we visualize this thing? Well, if I set a couple ways to think about this, and we asked you to do this early in the semester, if I were to set one of the variables equal to 0, then I get a line in a plane. So if I set x equal to 0, I get a line in the yz plane. If I set y equal to 0, I get a line in the xz plane. You know, if I set z equal to 0, I get a line in the xy plane. So sometimes it's useful to get an idea for the picture by doing that. So for example, when x and y are 0, what is z? You know, you could set two variables equal to 0 and you can get your intersection points. So let's show how you might construct that. Go to the next page. So this is not easy to do. I've made a point to try to get you to understand that. It's not easy to visualize these things in 3D. So let's try to draw it. Here's our z-axis, and then here's our y-axis. Here's my x-axis. So I'm trying to get some, you know, some sort of perspective here. So if I look at my equation, I know that when z is 0, or excuse me, when x and y are 0, what is z? It has to be 6. So I can just imagine that there's this point right here that is important. It's the point 0, 0, 6. Now, what if I set, for example, z and x is 0? If I set z and x to 0, I get y has to be 2. So this is the point 0, 2, 0. And then lastly, if I were to set x and, z and y equal to 0, I get x equals 3. So this is the point 3, 0, 0. So now this is going to be tricky. So what I'm going to do is I'm going to get a different color here. I'll get this blue. I like that. I'm going to try to draw a line from here to here, and then a line from here to here, and a line from here to here. So what I need to do, this is what makes things difficult, is I need to describe this three-dimensional region using equations. Now you might say, well, didn't you just describe it with 2x plus 3y plus z? So let's remind ourselves that that's the equation of, but don't forget the plane is 2x plus 3y plus z equals 6. That's the plane. All that is the equation of what's inside that blue triangle. That doesn't mean what's underneath it. We want to describe that triangular prism. That's what we need to describe. That's what the difficulty is. So the way you do this is you do what we did in 2-dimension. You fix one variable and you ask, how do the other ones move? And then you fix that variable and you ask how the last one moves. So this is a little more difficult to learn than you might expect, but we're going to give it a shot. So does anybody have a question right now? So again, I want to describe that whole triangular region, not even a triangular region. It's like a prism. So let me write this down. So D is a solid. So what does it look like? It looks like this. Now behind it you have, I'm going to try to dot these so you understand that that's sort of what it looks like. So it's not a plane region, it's some solid. I have these things. Damn. I have all kinds of little mathematical creatures I could help, but I don't have that one on me. Okay. So we need to describe D because that's what we want to integrate over. So if you look at the problem, I say there's 6 ways that you can integrate. So I say there's dx, dy, dz, there's dx, dz, dy. How do we want to do it? So let's pick a way. So we can describe D in 6 ways. So let me explain what these things mean. So if we want to integrate in, say, dz, dy, dx order, we first fix y and x. Second, so not only do you fix y and x, so okay, let me be very clear. Maybe I'll be even more clear than what I was doing. So the first thing you do is you fix y and x, then ask what z does. Next, so once you do that, once you have z out of the way, then you fix x and ask what y does. And then lastly, ask what x does. Does anybody have a question about that? Comments, concerns? We're almost out of time. As I said, this is not easy to do. But once you get it down, you'll be like, oh, okay, cool. All right, so that's what I want to do. So if I go back to my picture, assume I'm going to fix x and y. Well, what does z do? Well, you already know that. You have an equation for it. You know exactly what z does. It goes from 0 up to the equation of the plane. So let's note that. So for fixed x and y, z is always greater than or equal to 0, and it's always less than or equal to 6 minus 2x minus 3y. I got that from the equation. Hold on one second. I got to let my in-laws in. Ponder that. I don't know. Amy, we have visitors. Hold on, I'll be back. All right, I'm here. Sorry, we got visitors here because my kid broke her arm. We're breaking the law. The governor's going to be mad. As long as we keep it under 10, right?
Social distancing, man.
Yeah.
No way.
All right, so seriously, does anybody have a question about this? All right, cool. All right, so that's where z ranges. So that means when we integrate z, this is where it goes. It goes between these two values. Okay, now once we get that out of the way, once we get z, then we ask ourselves, where does y range? So this part is not so easy, because now you have to ignore the 3 dimensions. Now just go down in this triangle that's in the xy plane. The triangle in the xy plane, what is this line? So what's useful is to say, okay, this line is, what is it? It's y equals, well, what's the slope? Well, we know what the y-intercept is. It's something times x plus 2, correct? Because it goes through the y-axis at 2. And then what is the slope? Well, another way to think about this is you need it to equal 0 when you plug in 3, right? So when I plug in 3, the y has to be 0. I'm pointing at it like you can see that I'm pointing. When I look at this intercept here, when I plug in 3 for x, I better get 0. So that means that this slope has to be negative 2/3. That's what it tells me. So now this is, again, this is not easy. It might even be a little easier if you take the x and y axis and just draw it, just draw that triangle in the plane instead of looking at the 3 dimension. Again, this is not easy. And I'm trying to go at a reasonable pace, but to do this is it's good practice, but it's not easy to learn. I remember learning. I was like, screw it, what the hell. Okay, so what does that mean then? Well, that means, so for fixed x, what is z or y range? Well, y range is between this and negative 2/3 x plus 2. Okay, now here's the rub. So what's the integral we get? So this is kind of how you need to think about this. The integral we want is 2x, and the dv we wanted to do was dz dy dx. So now we have our bounds. Where does z go? It goes from 0 to 6 minus 2x minus 3y. Yikes. Where does y go? Y goes from 0 to negative 2/3 x plus 2. And then lastly, x goes from 0 to 3. Yikes. Now, what I'd like you to do is do that for the other 5 ones. It's actually not that hard once you get the equation of all those lines. But once you learn how to do it, you say, oh, it's easy. But learning it is the hard part. But once you figure it out, once each one of you has your own come to Jesus moment with it, or come to Allah moment, or come to whoever you want to, come to O'Grady moment, once you have that, like, oh, okay, I get it now, you're going to be like, holy hell, how did I ever think this was hard? But right now, it's chaos. And then that was just setting it up. We didn't even try to integrate this stupid thing yet. All right, does anybody have a question about this? All right, so if you don't have questions, what I'm going to do is stop here, and then I'll let you think about these other problems, and then we could talk more about them on Monday. Does that work for you guys? And then I'll post this lecture a little later. I'm going to save the whiteboards right now. I hope I didn't. Yeah, it says I saved them. And then I am going to stop recording now. Does anybody have a question before I do that? I'll take your silence as no.